Section 9.4 is called polarity of a transformer. And what we're going to look at, and don't overthink this, these are just definitions. The thing to remember when we're making these definitions is that these things are defined based on the construction of the transformer and how we wind the transformer. We could wind it in one direction, we could wind it in the opposite direction and get different results. But the thing I think it's important to remember is that this transformer, we don't have access to the inside of it. We really only have connections to the voltage terminals on the primary side and on the secondary side. So, we're limited as to what we can interact with. And so what we have to have is something that we call polarity marks so that we know how to connect this transformer properly. Of course, those could be verified with meters to make sure. But, normally with a transformer, they'll have something called polarity marks so that you would know that you were connecting the positive of one side to the positive of the other side. And, that's what you work off of when you're dealing with it. So let's explore how that comes about and look at some examples of this. Okay, so when we're looking at figure 9.5, we see that there are two fluxes. And, this is the linkage flux, leakage flux, and mutual flux. But at the same time, since they're both created by this magnetizing current, we can say that both of these, the flux mutual and the leakage flux, we can say they're in phase with each other, because as this one rises, this one is going to rise too, because they're created by the magnetizing current. So that, they would reach their peak values at the same time. They would reach their 0 points at the same time. And it goes to follow that the induced voltage here, that's really coming from the mutual flux here, it will also reach its value at the same time as this does, because of the linkage here, right? There's no delay in this thing. So let's say that during one of the peaks, and all this is based on sinusoidal values, right? So that during one of the peaks, we find out, and we have a way to measure, say, that primary terminal 1 is positive, and secondary terminal 3 is positive. So what we want to say when we do that, we want to use polarity marks to say that these two terminals will always have the same polarity as we go through cycles. Now, at the same time, we could have also used 2 and 4, and said if this is positive here, then that would be positive here. But normally what you do is you select the first terminals. And again, what that says, all that says is that, when this terminal 1 is positive, then terminal 3 is positive. And that has a big deal, it has a major consequence, so that we know how to connect the primary and the secondary sides to whatever it is that we're dealing with. Now, we'll get into all those specifics later, but these marks on the transformers are called polarity marks. And, that's just another definition that we need to know as we're working and getting familiar with transformers.